Okay, we're back because we got rudely interrupted by that last video. So I want to get k by itself, and of course this turns into a 1. So now I'm just going to divide by 2. And so now I know that k equals natural log of 2 all over 2. So I have a brand new equation, which is y equals, remember c was 2, and now we have e, and in place of k, we're putting natural log of 2 over over 2 times t. And so the only variables that I should have left are y and t. T is the new x. We need to make a series about that for Netflix. And so now I want to find out what is y when t is 3. So keep in mind y is the dependent and t is the independent. So now I'm just going to plug in 3 for the t. So y equals 2e natural log of 2 over 2 times 3. And of course, I can either leave it like that, which is exact, or I get out my trusty hamster and I type it all in. And there's my final answer. So I started with the generic one. I integrated it. I took the antiderivative. I plugged in the initial condition here, and I was able to solve for c. It's always nice when t equals 0 because that's the initial, aka the beginning when time is 0. That'll help me solve for c. And then after I had that, I was able to set these in to solve for k, because remember you have 2 variables that you need to really get rid of in order to get all the way back to what was my equation to start with, and that being the c, the initial condition, and then the k, the constant of growth. And then I was able to actually do the last piece, which is solve for y when I know t is 3. In other words, this would be my final equation, again, with only a y and a t as the variables. So here's a new twist on this one. So I have my rate of change for p with respect to t. That was kind of nice that they told me it was with respect to t. Is proportional to, so that means being multiplied by some constant k, to 10 minus t. And again, I want to get all my t's and p's on the same side. So I'll move this over. And then I don't have to worry about any p's. But notice I did distribute. And now I'm ready to integrate. So of course on the left side I'll end up with a p that I didn't have before. And so remember, all of this is just a constant. So when I power it back up, I'll have a t to the first. And this is the coefficient on t, so when I power that back up, I'll have the coefficient, and then t will power up and divide by 2. And then we'll put the plus c over here. And then I suppose the only thing that I could really do with it is rearrange the order. So I'd have negative k over 2t squared plus 10kt plus c. And I don't have any initial values, so I can't do anything with it, so it's just going to stay generic.